Hi everyone, welcome back. Looking at parallel lines, perpendicular lines, and if they're oblique or not perpendicular or parallel. So let's have a look at the cases. We could spend ages with diagrams and showing you the actual cases on the grids, but I'm thinking about at this point in time, other than making another video on it with the grids, is how many people are just sitting in an assessment and you don't have time to draw it, or you don't think about drawing it, or it's too hard to draw it, and you need to know basically what the rules are. So common for a year 11 assessment everywhere I've taught to just put up a bunch of lines and say which ones are parallel, which ones are perpendicular, and which ones are neither. And sometimes some people will just put up a whole bunch of them, and it's up to you to look at them and see which one. So a lot of it's about observation. The first one here, they're both 2. As long as it says y equals, that is the gradient. The number in front of the x is the gradient. I see so many students write the gradient as 2x. So the x is not the gradient. The coefficient of the x, the number in front of the x is the gradient. So if you want to be fussy, you could say that one, the first line has a gradient of 2, and the second line has a gradient of 2. So the gradients are the same. Some people will get really fussy and say that m1 equals m2, and they can go a step further and say they're both 2, and then they'll say therefore they are parallel. So parallel lines, if you've got it written as y equals and y equals, all it means, by the way, these 2 lines have the same gradient and they've been moved either up or down from each other. So this one's actually lower down than that one, or you could say that one's higher up than that one. Now here's one that mucks people up all the time. Gradient first, I've forgotten to mention. Gradient first, all these topics. Latest thing I'm thinking about saying to people all the time, but we said it, but making it even clearer. Gradient first. What's the gradient for this one? It's a 3. What's the gradient for that one? It's a 3rd. So we know that gradient of 3 and a 3rd means different gradients, they're not parallel. So let's have a look at what people think about. The rule for perpendicular is m1 times y, m2 is minus 1. I'll go through that on another video. So if I went 3 times 1/3, does it equal minus 1 or negative 1? No, it equals positive 1. So that means these 2 are not parallel and they're not perpendicular. So we'll refer to them as neither. If I drew up a quick diagram, a gradient of 3 means you're going across 1 and you're going up 3. So there's our line with a gradient of 3, just freehand, even rough as anything. This one means we're going across 3. This is a 3 on 1, across 3 and up 1, so across 3 and up 1. And you can see pretty obviously, if I drew it there, there's a right angle, and there's nowhere near as big as a right angle. So a common sense approach is you could just look at it and see if you drew a diagram, but so much quicker just to say, what's the gradient, do they multiply by minus 1? So personally I look at that and go 3 times a 3rd, I'd probably just write 3 times a 3rd equals 1, which does not equal minus 1. You can see what you can get away. I used to have a tendency to write as little as I could, but if I wrote too little, I knew I'd lose marks. Or more than that, or worse than that, I make silly mistakes everywhere. A little bit tricky, this one. The gradient, this one does muck up people when they put in the test. The gradient for that one is minus 1/5. So remember there's really a 1 there, so that's just a 1/5, and of course it's a negative 1/5. Negative 1/5. The second one is a gradient of 5. Now I can just look at that and go, that times that is negative 1, so therefore they are perpendicular. So let's write the rule properly. M1, M2 equals minus 1/5 times 5, and most people will be okay with just saying that's minus 1, and then you can say therefore they are perpendicular. You don't have to write the whole word for perpendicular. Now the first and only tricky case I've got here, you need to make y the subject first. Remember we're talking about gradient first, and get the gradient we need y equals, and we need y equals for both of them. So if I make y the subject here, the 2x becomes a minus 2x on the other side, and the minus 3 becomes a plus 3. Some people I know still need me to go take 2x, plus 3, and you can see that that ends up being all on the right hand side. So we now know that the first gradient is minus 2. So what's the second gradient? Pretty revolting. What do? There's so many ways to do it. Personally, I wouldn't have just gone straight to y equals. I would have put the 2y on the other side. Actually, I would have done it in my head. Actually, I'll do what I normally do. For those who are comfortable with it, I would have said that's 2y on the other side, 2y on the other side. That makes this a positive x, it makes that a positive 10. But everything inside me says, no, it'll muck too many students up. But if you're okay with that, that's all you need to do. Let's have a look at it. If I add 2y to this side, I add 2y to that side. And I end up with x equals minus 10 plus 2y. I want the 2y by itself, so I've got to get rid of the minus 10. If I add 10 to that side, I add 10 to that side. Oh, it's too long for some people. And you've got 2y equals that. So by habit, I would make 2y equals x plus 10 because we are creatures of habit, and the less you have to think, the better. If I divide this one by 2, divide that one by 2, and that one by 2. Remember, we're dividing all three of them. You can put them over the 2 in one go, but I tend to avoid that. And you've got y equals, and you can see it here now, even if you didn't want to write another line down, you can see that the gradient is the half. Remember, there's a 1 there. So that's a gradient of a half. What's my rule? M1, M2 is minus 2 times a half, which is minus 1. That's terrible writing. Picks up the equals. M1 times M2 is minus 2 times a half, which is minus 1. You can say, therefore, they are perpendicular. And the question's done. So you can see if I really wanted to make it tricky, put some fractions in, put more negatives in, maybe rearrange the question where it's in an unusual form to see if it makes students up. Oh, thanks for watching. I hope you found it helpful. If you do, please just let your friends know. I'll see you in the future.